Hi everyone, welcome back to the channel. So today we are going to continue one of the most important topic under AI, that is your state space representation. So in lecture number 23 we have already done with the introduction, examples and features of this representation. Now I will share with you some advantages or disadvantages of using state space representation in any AI tool. So now let's just continue the session with its positive points. So the first reason why we use this representation is its systematic problem solving. All right. So this particular state space representation provides a structured framework for systematically exploring any possible solutions of a complex problem. And this representation always enables any AI system to break down any complex problem into manageable steps so that we can easily and systematically solve that complex problem within few steps. All right. Next positive can be your flexibility. So as we all know, in AI, in all AI systems, the flexibility of system is very important. So state space can be applied across various problems like pathfinding, autonomous driving, right, planning, game playing, etc. And due to the adaptable nature of AI tool, or due to the adaptable nature of any AI system, we use state space representation. Basically, it is a universal model that fits many scenarios from simple puzzles to complex decision making processes. That's why we should use a state space representation for its flexibility. That is related to the adaptability also. All right. Another point is the foundation of search algorithms. Foundation of your search algorithm. So we uses search algorithms like depth first search, breadth first search, and A star search. We have discussed all these three types in data structures, right? So these three search algorithms rely heavily on state space representation, and these algorithms helps us to navigate the state space to find optimal paths or solutions, making state space easier for the developing AI search strategies. All right. Next positive is the transparency and traceability. It plays a very important role in state space representation. Okay. So students, under your transparency and traceability, we have already discussed about different states under this representation. So here each state and transition that we have discussed can be tracked, making it easier to trace the path of the solution. That's why we use transparency and traceability. This traceability aids in debugging. Basically, traceability aids in debugging and understanding how a solution was reached, and which is beneficial in real-time decision making and diagnostics. All right. Another positive is the optimality and cost efficiency. So state space allows for cost analysis of path. It allows for the cost analysis of paths, which can lead to finding optimal solutions just by minimizing the cost. For example, time, distance, computational resources, anything can be minimized. Another positive of using state space representation is the application to constraint satisfaction problems. So, problems with any specific constraint, problem in AI with any specific constraint, like if we talk about n queens problem, if we talk about Sudoku problem, it benefits from state space representation by treating the constraints as rules. Constraints are what? Constraints are the rules that guide the search toward feasible solution. That helps us to get a feasible or easiest or best solution at that particular point of time. All right. So next, now just talk about negatives of using state space representation. Why we should not use this particular thing in AI. The first reason is exponential growth and complexity, that is combinatorial explosion. As we talk about some complex problems, so for complex problems, the number of possible states can grow exponentially. That can lead to what is known as the combinatorial explosion. All right, this growth quickly becomes computationally infeasible even with modern technologies, as a state space may contain billions or trillions of possible states. We have discussed about 6 to 7 states in previous lecture, right? But generally in AI, state space representation has known they may or may not contain billions or trillions of possible states. Another is high memory and computational requirements. So storing and processing large state spaces demands significant memory. It demands significant memory and computational power, and this can be limited factor for complex problems, making the state space approach challenging for resource constrained environment. All right. Another is the infeasibility in continuous spaces. So this representation is basically more suited to discrete problems. All right. State space representation is more suited to discrete problems. And when the problem involves continuous variables means what? Like controlling a robotic arms movement in real world value space, etc. This is the continuous variable. Okay. Discretizing these variables may lose precision or require additional method to handle. That is the infeasibility in continuous spaces. Next is the lack of scalability. Lack of scalability. Some problems like multi-agent systems and environments with many variables results in enormous state spaces that cannot easily scalable. All right, so attempting to model these systems with state space representation can quickly become impractical. That is why we say it has a lack of scalability. Another is dependence on effective heuristics. So, for many basic problems or many complex problems, heuristics are basically required to guide the search effectively through the state space, and without any good heuristics, the search can be inefficient. All right, that is why we call it as dependence on effective heuristics. Another is potential redundancy. Whenever we talk about state space graphs, many uh, state space graph may include many redundant states leading to inefficiencies. All right. For example, if we talk about any AI agent that can reach the same state by different paths, this is the destination state. If any AI agent can reach the same state by different paths, the representation may end up with unnecessary representation. That is the potential redundancy. All right, so all these are some positives and negatives of using state space representation in AI. So I hope students everything is clear to you. If you have any doubt, you can definitely comment below. I will try to give a reply as soon as possible. So thank you so much.